Hello, everybody. It's Mrs. Pound, and I'm back with more from Chapter 3.3 on volcanoes. Today, we're going to talk about volcano zones from Section 332. So, our objectives today are to explain where most volcanoes occur and why, and to compare volcanoes along the mid-Atlantic ridge with the volcanoes along the Ring of Fire. So, most volcanoes occur on plate boundaries. That's why these chapters are lumped together about continental drift, plate movement, earthquakes, and volcanoes because they are all interrelated. Now, the two types of plate boundaries where we tend to find this are divergent plate boundaries and convergent plate boundaries. So, tectonic plates spread apart and magma rises through the gap to form a volcano at a divergent plate boundary. And these type of eruptions tend to be very gentle type eruptions because you just have the spreading of the plate and the magma oozing up to the top in the gap that is created. These happen along rifts, which are a deep crack that forms between two tectonic plates as they separate, in places like Iceland. This is how the island of Iceland is believed to have formed because there is actually an island just off of Iceland that started forming in the 60s just this way. It just basically came out of nowhere along the mid-Atlantic rift um, there and started to form close to Iceland. So, an example of this is again the Mid Atlantic Ridge. The other place we see volcanoes are along subduction zones. This is a place where one tectonic plate is pushed under another tectonic plate. Some scientists believe volcanoes are formed in a subduction zone when oceanic plates subduct under continental plates. The heat from the collision melts the mantle and magma is forced through. So we have continental plate, oceanic plate going under, heating up, and then those mountains that are forming from being pushed up there, the magma comes up through cracks and is forced through. These tend to be more violent volcanoes with more violent eruptions than at our divergent plate zones because the magma is under more pressure. Um, when it's divergent, it's just kind of seeping up through. With these convergent plates, it's put under more pressure. And an example of this is around the Ring of Fire. The Ring of Fire is a ring of volcanic activity around the Pacific Ocean. And that is an area where, if you look at your tectonic plate map, there's a lot of subduction zones there. There's a lot of those convergent zones. And so that is commonly called the Ring of Fire. And it was recognized that there was a lot of volcanic activity in that area even before plate tectonics was proposed, the theory of plate tectonics. Now, the most violent volcanoes are created through oceanic plate collision. And this is because you have added steam from water and more carbon dioxide also bubbling up through with that lava. And it's making those gases that are released are making these volcanoes even more violent. So those are the most violent due to the pressurized gases that end up coming out of them. So our objectives were to explain where most volcanoes occur and why. So along plate boundaries, especially the Ring of Fire, and compare volcanoes along the Mid-Atlantic Ridge with the volcanoes along the Ring of Fire. Mid-Atlantic Ridge being less violent, calmer, and along the Ring of Fire, they tend to be a little more violent and due to subduction, where Mid-Atlantic Ridge is due to uh, divergence. So don't forget your 5 questions, and I will be back with more about volcanoes.